Hi everyone, we continue our learning on the precipitation titration. So this video will be discuss a few example or a few exercise related to the precipitation titration. So as you can see from this slide, this is one of the example or one of the exercise. So we have to read the question carefully and try to extract all the information given. Uh, a 5 ml of sample of pesticide containing chlorine was diluted to 25 ml. So meaning that this 5 ml of sample containing of chlorine and diluted to 25 ml. Then nitric acid was added to 10 ml of this diluted solution to convert all the chlorine into the soluble chloride ion. 50 ml of 0.215 molarity of silver nitrate added to the sample to precipitate all the chloride. So here it mentioned excess silver nitrate, meaning that this is a Volhard method. So they have a back titration, then titrated with 15.80 ml of 0.2 ml of potassium thiocyanate using Volhard method. So you can draw the back titration. The second titration, this is the back titration using potassium thiocyanate using 15.80 ml with 0.227 molar. So in the conical flask, it containing of silver ion in excess. So this one is a back titration. So the first titration is between silver nitrate. So silver nitrate containing of 50 ml with 0.125 molarity uh, was added to the sample. So the sample we put it in conical flask of 10 ml sample X, or we call it 10 ml of sample. So this sample containing of chlorine ion, chloride ion. Okay, so the 10 ml of sample was obtained from 25 ml of from the 25 ml of the original sample. So meaning that it's obtained from another 250 of another 25 ml of sample when we dilute 5 ml sample, we dilute it with into 25 ml. So this sample containing of uh, chloride and also containing of chloride. So write the chemical equation for the titration. So they have two titration in this case. First titration is between silver ion plus chloride ion to produce silver chloride. And silver in excess also reacted with thiocyanide to form silver cyanide. Okay, so the question is calculate the concentration of chlorine. Uh, chlorine, is a chlorine. Chlorine, meaning that this one should be Cl2 is containing of chlorine. And also Cl2 and also Cl2 is containing of Cl2 and also Cl2. Okay, so the question is calculate the concentration of chlorine with percent, meaning that gram per milliliter times 100. This uh, volume of sample we already obtained 5 ml is a given in the question. So what we can do is we have to calculate the mass of chlorine in the sample. All right. So this is the back titration equation. The silver will reacted with thiocyanide to form silver thiocyanide. So we have to calculate 2 moles of silver nitrate. Silver nitrate in the back titration and also silver nitrate during the first titration. So the initial mole of silver nitrate. So this is the initial titration. Okay, so we can calculate the concentration of we can calculate the mole of silver nitrate. So silver nitrate, because from the molarity, we know from the molarity. I repeat it many times already. From the molarity, we can obtain mole per liter. So we already know volume and molarity. We can calculate the initial mole of silver nitrate. So in order to calculate the mole, molarity should be multiplied by volume of solution. So in this case, 50 ml converted into liter and then multiplied by 0.25. So you obtain the initial mole of silver nitrate. All right. So what is the excess mole of silver in the back titration? So by using the information related to potassium thiocyanate, you can calculate the mole number. Because you know the silver will be reacted 1 to 1 with thiocyanate to form the silver thiocyanate. All right. Uh, so from the information given, 15.8 ml in 0.227. Therefore, 1580 divided by 1000 in liter multiplied by 0.227. So you obtain the mole number of excess silver. Okay, so this is the mole number of excess silver. So initial excess, so the mole number of silver treated with the chloride is the subtraction between the initial volume with the excess amount. So you can obtain the mole of silver nitrate reacted with chloride. 0.01 minus so 0.017163. So mole of chloride will be react with 1 mole of, okay, why is it so? Because the first titration, 1 mole of silver will reacted with 1 mole of chloride. So mole of chloride uh, is a mole of silver nitrate. So this is the mole of silver uh, chloride ion in the chloride ion in the 10 ml of sample. Okay, so now you have to calculate the mass. When you know the mole, you can calculate the mass, because mole is a mass over molecular mass. So in order to calculate the mass, this moles have to multiply with molecular weight. So this is a mix of chlorine, because the question said the sample containing of chlorine. So we know the chemical formula of chlorine is Cl2. So the mole number multiplied by the mole number multiplied by molecular weight of chlorine 35 with 2 because of Cl2. So 0.07163 multiply by 2, 5086. So this is the mass of chlorine. So we know the mass of chlorine in 10 ml. We know in 10 ml of sample, it containing of 0.086 gram of Cl2. So in 50 ml, is it 50? No. Uh, in 25 ml. In 25 ml, it containing of X. So X is, okay. So 0.6 multiplied by 25 divided by 10. Okay, so 1.2715 gram in the 25 ml. Okay, so this is the amount. All right. So, in order to know the percentage of concentration of chlorine in the pesticide is a mass over volume. Okay. So this mass over volume 5 ml divided times 100. 25.43%. Okay. So moving to the next question. A piece of salted fish sample. Fish sample was digested in strong acid to produce a solution. The solution was titrated. Okay, titrated with 26.7 ml molarity of silver nitrate using Moore method. Moore method is direct method to determine the chloride ion. Calculate the mass of chloride ion in the salted fish. Okay, this is a direct method, meaning that silver will react with chloride to form silver chloride. And then we know the titrant is silver nitrate is at 21.7 ml and 1182 molarity. So here in the chemical flask, it containing of sample with chloride ion. So it's a very straightforward. We can calculate the mole of silver nitrate, and then by using the relationship between 1 mole of silver in 1 mole of chloride, you can determine the mole of chloride. From the mole of chloride multiplied with molecular weight of chloride, and then you can get the mass of chloride. Okay, so this is the equation as I mentioned just now. So we know the mole of chloride reacted with 1 mole of silver. So we is it the silver nitrate from the molarity mole per liter. So we can obtain the mole of silver. So 26.70 minus divided by 1000 multiplied by, so you can obtain 0.00315 mole of silver. So it's mole of silver is equivalent to mole of chloride. So when you know the mole of chloride ion by using the molecular number of molecular weight of chlorine 35.5, so you can calculate the mass of chlorine. Okay, so 0.35.5, so you obtain 0.112 gram. Okay, so this is the mass of chloride ion in the sample. Okay, So this one is a very straightforward. You can complete the table below. 1, 2, 3, 4, 5, and 6 for the three methods in precipitation. So we have a Moore method, a Volhard method, and also Fajan method. So the direct titration using chloride, this one is a Moore method. So Volhard using thiocyanide. This one is Volhard method. So indicator reaction is a silver plus chloride to form silver chloride. Fajan method, color is the ink point. It should be pink. It should be pink, I think. It should be pink in the Fajan. It should be red or pink color when you use the fluorescent is the indicator. So it should be red or pink. Okay. So this one can be red or pink. Titration for Volhard method is the what is the titration? Is a silver with back titration thiocyanide to form silver cyanide. So color it should be, I think it's red color. Yeah, it's a red color. So you can double confirm all this answer on the previous slide. All right. So I think that's all for this. That's all for this subtopic on the precipitation titration. All right. See you again on the next video on the last subtopic in the trimetric analysis, which is redox reaction. Okay. See you again. Bye bye.